Hi everyone. So today we'll see how this banker's algorithm works. It is one of the famous algorithms used for deadlock avoidance, and it is also one of the important topics of your syllabus. So let's see using one example. So in this example we have taken 5 processes. This type of question will be given to you in your exam, so we'll have to solve it, and using this banker's algorithm we have to find out the safe sequence of the execution of processes. That means what? We have to find out the order of the execution of these processes so that we do not get the deadlock in our system. So this question will be given to you, or this type of question will be given to you in your exams, where the processes will be given in your system. There may be several number of processes working, but we, for simplicity, we have taken only 5 processes here, and some data structures will be given to you. As in the last video I told you, there will be having 4 data structures we will be using in this banker's algorithm. 3 are mentioned here and 1 we will calculate. So these are allocation, max and available. Allocation is the resources. These are the processes, and this A, B, C, these are the different types of resources, and these values are the instances of these resources. So allocation is the system has allocated these number of instances of these resources to these processes. It's like for process P0, system has allocated 0 instance of A resource, 1 instance of B resource, 0 instance of C resource to process P0. Likewise, for process P1, 2 instances of resource A has been allocated to process P1, 0 instance of B and 0 instance of C. Likewise for P2, P3 and P4. So this was your allocation. This is max. This is the maximum number of resources, instances of resources these processes can request for. So maximum P0 can request for 7 instances of A, 5 instances of B, 3 instances of C. Likewise for P1, P2 and P3 and P4. And this is the available. This, in this current situation of the operating system, we have, after all this allocation, we are left with A 3 instances, B 3 instances and C 2 instances. So this is the current situation. We have these number of resources left, and this has already been allocated, and maximum to maximum this request can happen in your system for these resources by these processes. So if we want to find out this safe sequence by using banker's algorithm, the first step is calculate the need matrix. Calculate the need matrix, and this need matrix is the 4th data structure, and we'll calculate it here. This is the need. This was your question given to you, and this is the first step. We'll calculate need. So all these are the 4 data structures. This need is whatever maximum they can request for and whatever the allocation has been done. So this need for process P0 for the resources A, B, C is 753 minus 010. So it is 743. So this is the need of process P0 in future. And P1, it is 122. It is 600. How 600? 902 minus 302. Likewise for process P3, it is 011, and for process P4 it is 431. So this is the need of all these processes, and we have calculated using this formula, max minus allocation. It was very simple, I guess. Now second step is whatever need you have calculated, just compare it with the available number of resources in your system. If this comes out to be true, then we have to update the available, and this available now becomes the present available plus the allocation of that resource. This means what? If we can fulfill the need of any process, so we will do what? We will take back the allocation of this particular resource, and we will add to the available number of resources. So our available will be updated, and the process will exit from the system, and the available resources will be used by the other processes. So using this second step, let us start with process P0. So what P0 says, need of P0 is 743. This is the need of process P0. So 743, we will compare it with the available 332. So this is false. So we will leave this process and we will move on to process P1 because we cannot satisfy this need. So we will move to process P1. P1 need is 122 and it is less than 332. Yes, this is true. So we will update the available. Available value will become the present available value plus the allocation given to this process P1. So allocation was 200. We'll take these resources back and it will become 532. So it is 532 now available. So now move on to process P2. P2 need is 600 and it is not less than 532. So again this is false. Move to the other process P3. Need is 011 and it is yes, it is less than 532. It becomes true. So available value now becomes 532 plus the allocation of P3, it is 211, so it becomes 743. So we'll update here 743. So likewise for process P4, we will check the need of P4 is 431 and it is less than 743. It is our new available 743. Yes, it is also true. So we'll update again the available. It is 743 plus the allocation of P4. It was 002. So it becomes 745. So we'll update here 745. So again we'll see that these two processes are having false value. So again we will check for these. So process P0, it is 743. We will compare it with this new value 745. Yes, it is true. So we'll update the available and it becomes 745 plus this allocation. This is 010, so it becomes 755 and we'll update this to 755. Okay, so now one process is left. It is P2. P2, the need is 600 and we'll compare it with this 755. Yes, it is true. This condition is true. We'll update the available. Available now becomes 755 plus the allocation of P2, that is 302. So this becomes 1057 and all these processes have been executed. So we have these true values, and in the order we have executed these true values, that will be our safe sequence, and this 1057 is the new available, that is the available number of resources in the system after execution of all these processes. So we have got the answer. Our safe sequence is now, safe sequence comes out to be P1, P3, P4, P0 and P2. So this is our safe sequence. If our system execute the processes in this order, we will not be having any deadlock, and also in the end available number of resources for A, B and C, it is 10, 5 and 7. So we have used the banker's algorithm and we have found out the safe sequence and the number of available resources in the end. So this was simple. So please try more questions of this type using the same formula. Thank you.